Dear students, very good afternoon. Today we are going to see another important problem under Laplace transform of periodic functions. Laplace transform of or transformation of periodic function. Periodic functions. So this is an important problem. So the problem here is find the Laplace transform of triangular wave function triangular wave function f of t equal to t 2a minus t 0 less than t less than a and a less than t less than 2a with f of t plus 2a equal to f of t. So we have seen our first problem as rectangular wave function. For that we have given f of t equal to 1 and minus 1 for 0 less than t less than b and b less than t less than 2b. Now we have mentioned it as triangular wave function, where we have taken f of t equal to t 2a minus t. I hope you all remember the first problem, very first problem we have discussed. It is f of t equal to 1 minus 1 for 0 less than t less than b and b less than t less than 2b. So in the question we have seen it as rectangular wave Laplace transform. It is a rectangular wave function. Rectangular wave function. Now in the question we have given triangular wave function. Triangular wave function. So here they have given f of t. Instead of constant we are having the functions of t 2a minus t 0 less than t less than a and a less than t less than 2a. They have also mentioned that it is a periodic function by giving the proof that f of t plus 2a equal to f of t. So f of t plus p equal to f of t, where p greater than 0. So here 2a should be greater than 0. 2a should be greater than 0. So they have given it as the present question. Now we shall know, dear students, for you these two equations may look like similar because both are having a same intervals. Here intervals are for b, here intervals are for a, but both are looking like same. But as I told you already, here the values are constants 1 and minus 1. Here you are having the variables t and 2a minus t. The rectangular wave function will be in the form of rectangular wave and triangular wave. Here the rectangular wave will be in the form of it will be something like, okay, it may be like this. Okay, the triangular wave is something that looks like this. Okay, so to be more clear, I shall draw this rectangular wave very neatly. So kindly take it. So it may be look like this. Okay, it may be look like this. You will have a line, a rectangle, a line, and a rectangle, and so on. Okay, it will be like this rectangular function. So I shall tell you here, for the rectangular wave function they have given two values of f of t. Let us take this as t, and the t values are given by 0 to b and b to b. So we have to take 0, b and 2b. For 0 to b we are having 1, and for b to 2b and for b to 2b we are having -1. So it is -1, 0 and +1. So for 0 to b the limits are given by this. The limit, it may be look like this. Okay, it may look like this. And for b to 2b you are having like this. So it forms, I am taking the same thing. See, 0, a and 2a. If I substitute t to be 0, I will get this. I will get this point. If I substitute t to a, but see, you have to look into this. These values are for t, and this is a, and this is 2a. Here minus a. In the bottom you will have minus 2a. All these explanations are not necessary for your exam point of view, but being a mathematician, it is my duty to explain you the concept. Okay, because solving a problem can be done by anyone. Okay, that even you can solve. These problems just only requires formulas, but you have to be well versed with the concepts. Okay, that is what I am expecting. So here, if I take, see, I shall use different color, red. Okay, I shall take different color. It is 0, -1, -1 and +1. Okay, 0 -+1. Here it is b, here it is 2b. Okay, now here you are having -a, -2a. here it is a and 2a. So here a 2a for t. See, this is f of t. This is f of t. The x-axis represents t, whereas the y-axis represents f of t. So here this is f of t. Okay. Now if I take t equal to, see, if I take t equal to 0, I will get f of t to be 0. If I take t equal to a, f of t to be a. If I take again t equal to a, I will get 2a minus a, again to be minus, again to be a, and if I take 2a, I will again get 0. Okay, because 2a minus 2a will become 0. So it will form a triangle. It will form a triangle. It will form a triangle. So I hope you now know the difference between triangle. You now know the difference between f of a. Sorry, you now know the difference between rectangle wave function and triangle wave function. Okay. See, I shall draw it. This is t. This is f of t. And here you are having 0, t, b, and 2b. Okay. So here for t equal to 0, here I am having 1, here I am having minus 1. For here I am having 1, here I am having minus 1. So for all the values from 0 to t and for t to b, see, actually you will have like this. You will have the values like this. Okay, 0, and this is, yes, you will have like this. See, this is 0, b, 2b, this is 1, and this is minus 1. Okay, so if you are having like this, okay, I am telling you very slowly. If you are having like this, you will have for all the values, for t equal to 0, you will have 1. For t equal to any value, all the points will come to this till this t reaches b. So you will get a rectangle here. From b to 2b, okay, from b to 2b, the values will take this. Okay, these points, that is minus 1 till it reaches minus 2b. So you will have this rectangle. So you will have this rectangle. So this is a rectangle function and this is a triangle function. So even though the function f of t, see, even though the function f of t looks similar based on the intervals, you have to substitute and find the values, and you have to draw in order to confirm whether they are rectangular wave or triangular wave. Okay, and there is another wave called square wave, which is a part of this rectangular wave. Okay, so you have to be very clear. Now only this is very basic and fundamental. Okay, this is very basic and fundamental. Now we are now only we are going to the problem. Okay, now only we are going to the problem. So take down the problem. Use the Laplace transform of triangular wave function. Triangular wave function. F of t equal to t for 0 less than t less than a, and for a less than t less than 2a you are having f of t as 2a minus t. So this is your question. Okay, this is your problem. Okay, this is your problem. For this problem I have explained you the concept of both rectangular wave and triangular wave. Now we shall go to the solution. So solution. So they have given so given f of t equal to they have given the values as t for 0 less than t less than a, and 2a minus t for a less than t less than 2a, and they have given with f of t plus 2a equal to f of t. So this problem is very important. They have given the hint. Okay, because if the function is periodic function, it will satisfy f of t plus p equal to f of t. F of t plus p equal to f of t. Definitely the periodic function will satisfy this condition. So in the place of p we are having 2a. So so that p equal to 2a. So you can easily guess the value of p from this condition, or else you have to subtract the final value minus the initial value of the intervals. So from this you will have p equal to 2a minus 0, that is equal to 2a. Okay, so you can write f of t is a periodic function with period 2a in the interval what interval? Open interval 0 comma 2a. The open interval 0 comma 2a. Okay, so now according to the Laplace transform of periodic function, we will have L of f of t as 1 divided by 1 minus e power of minus ps integral 0 to p e power of minus st f of t into dt. So we are having p equal to 2a. Our L of f of t will become 1 by 1 minus e power of what is p? P is 2a s. Okay, e power minus 2as integral 0 to what is period? Period is 2a, 0 to 2a into e power of minus st into f of t dt. Okay, so now this now See, now this interval can be split here into two. So you will have L of f of t equal to 1 by 1 minus e power minus 2as into inter 0 to a, okay, inter 0 to a, e power of minus st into what is f of t? F of t is t into dt, then plus integral a to 2a e power of minus st. What is f of t? F of t is 2a minus t into dt. 2a minus t into dt. So with this expression we have to solve the integrals. Okay, so how to solve these integrals? I am going to take this as integral u dv. Using that formula we can solve. So that is equal, first of all I shall write it as 1 by 1 minus e power of minus 2as into integral 0 to a t, this is my u, e power of minus st into dt, this is my dv, plus integral a to 2a 2a minus t, this is my u, and e power of minus st dt, this is my dv. So by using Bernoulli's formula, we will have, integral u dv equal to uv minus u dash v1 plus u double dash v2 minus etc. We have to stop this continuous process when u becomes, then the derivative of u becomes 0. Okay, so here this is u and this is dv, here this is u and this is dv. So what is our v? So for first we are having v equal to e power of minus st dt, and in the second case we are having v equal to the same thing. Okay, we are having the same thing, so it is not necessary to split it. So e power minus st into dt, that is equal to so we will have e power of minus st divided by minus s. This is our v. So for each and every time you have to integrate this v and you have to differentiate u. Keep in mind, you have to differentiate u all the time, you have to integrate this v all the time. Okay, u the differentiation, v the integration. Okay, you have to remember. So now you will have according to this formula, you will have the following expression. Okay, see, 1 by 1 minus e power of minus 2as into, this will become uv. What is u? U is t. What is v? E power of minus st by minus s. So uv minus u dash v1. So you have to differentiate this. You have to differentiate this, and you have to integrate this. Okay, which will give the next term, uv minus u dash v1. So it is this is nothing but 1. So 1 into e power of minus st e power of minus st divided by minus s into minus s will become s square. Okay, so if you differentiate this one again, it will become 0. So this is enough. This is enough. uv minus u dash v1. The next term will become 0. So after this, so the limits are 0 to a. The limits are 0 to a plus limits are 0 to a. Okay. The limits are 0 to a. Then plus, see now plus, you will have 2a minus t. This is your u. 2a minus t. Your v is e power of minus st by minus s. Then minus u dash v1. So u dash means you have to differentiate this 2a minus t. 2a will become 0 and t will become minus 1. So t will become minus 1 means 0 minus 1. 0 minus 1 into, you have to integrate this. So you will get e power of minus st divided by s square. The limits are a to 2a. The limits are a to 2a, and you are closing the bracket. Okay. So now you will have 1 divided by 1 minus e power minus 2as into t minus t e power of minus st by s minus e power of minus st by s square. The limits are 0 to a. Then the limits are 0 to a. Then this is common. What is common? T is 1 by e power of minus 1 by 1 minus e power minus 2 is common. Okay, 0 to a. Then plus minus of 2a minus t e power of minus st by s. This minus of minus 1 become plus. So plus e power of minus st by s square. The limits are a to 2a. a to 2a. Now you will have 1 divided by 1 minus e power minus 2as minus a e power minus as divided by s minus e power minus as by s square. Then this is upper limit. This is upper limit minus the lower limit. So we will have 0 minus e power 0 by s square. Then you will have plus. Here on substituting 2a you will have 0. 2a for this t means you will have 0. So 0 plus e power of minus 2as by s square. If you substitute the lower limit, minus 2a e power 0 Okay, 2a, sorry, it is 2a e power as, e power minus as. See, actually you are substituting 2a minus a. So 2a minus a will become a e power minus as by s, then a e power minus as by s, then you are having this plus e power minus as by s square, e power minus as by s square by s square. And this 1 by 1 minus e power as is common. Okay, this is common. Okay, I am having a lack of space here, so I think the letters are getting overwritten. So you have to watch clearly and carefully. You will have 1 by 1 minus e power of minus 2as into, is there any terms is likely to get cancelled? We have to check, but before that we shall write everything. Minus a e power minus as by s minus e power minus as by s square, minus of minus will become plus 1 by s square plus 1 by s square, then plus e power of minus 2as by s square, then you will have minus or plus. You have to check this. So we are having you have to check this, you have to check lower limits. See here yes, here we are having, if I substitute 2a, okay, we have to check from the previous term. Yes, so this is actually minus 0. This is actually minus 0, but it is not necessary to mention it. But here you see 2a minus a is a. This is for lower limit, but here you are having a minus, so you will have minus a. Okay, minus a e power minus as by s plus e power minus as by s square. Okay, so it is plus a e power minus as, it is plus, it is plus, it is plus. Okay, so you will have plus a e power minus as by s, then you will have minus e power minus as by s square. Okay, so you have to check whether we are getting all the things correctly or not. So how to confirm that? We have to get the terms cancelled. Okay, if only that we can confirm. So here you are having a e power minus s by s. Here you are having a e power minus s by s. So these two terms will get cancelled. Okay, these two terms will get cancelled. This term and this term will get cancelled. Okay, now the remaining terms are having the common denominator s square. So we shall write it here. We will have 1 divided by 1 minus e power minus 2as into this is 1 minus this is e power minus as and this is e power minus as. Adding these two, you will get 2 e power minus as and this is e power minus 2as. E power minus 2as whole divided by s square. Okay, so I shall simplify this as 1 divided by 1 minus e power of minus as the whole square into 1 minus 2 e power minus as minus e power minus as the whole square. Okay, e power minus as e power minus as the whole square. So now it will give you, now the above expression will give you the following thing, 1 divided by, this is in the form of a square minus b square. So you will have a plus b into a minus b. So 1 plus e power of minus as into 1 minus e power minus as into, see here you are having the denominator by s square. I shall write it separately. 1 by s square into, this thing can be a square minus 2ab plus a square minus 2ab. What is this? This will be actually plus, this will be actually plus 1. Yes, this is actually plus, no? Here you are having plus. So plus and this is plus. So plus, since you are having plus here. Okay. So now, so this can be written as a square minus ab plus b square can be written as a plus b whole square. So we have 1 minus a minus b whole square, a square minus 2ab plus b square can be written as a minus b whole square. So it is e power 1 minus e power minus as the whole square, So you will have 1 minus e power minus as. I shall write it very simplified form. 1 plus e power minus as into 1 minus e power minus as into 1 by s square into 1 minus e power minus as into 1 minus e power minus as. So these two things will get cancelled. These two things, the common terms in the numerator and the denominator will get cancelled. So you will get 1 minus these two terms will get cancelled. So you will have the following term the following terms. That is, you will have 1 by s square into 1 minus e power minus as divided by 1 plus e power minus as. So here we are going to apply the same idea which we had applied in the previous problem, or what we had applied in the previous problem. So I am writing it as 1 minus e power of minus as by 2 into e power of minus as by 2 divided by 1 plus e power of minus as by 2 into minus as by 2. So this will become 1 by s square of 1 minus e power of minus as by 2 divided by e power of as by 2 whole divided by 1 plus e power of minus as by 2 divided by e power of as by 2. So we will have 1 by s square into e power of as by 2 minus e power of minus as by 2 whole divided by e power of as by 2 plus e power of minus as by 2, that is equal to, I have already given you in the previous problem the relation between the exponential terms and hyperbolic functions. So this expression is in the form of C e power x minus e power minus x divided by e power x plus e power minus x. So this is equal to sine by cos, that is equal to tan h, tan hx. So we will have 1 by s square into tan h of what is x here? X is as by 2. So our L of f of t is given by L of f of t equal to 1 by s square of tan h of as by 2. So this is our solution. Where this f of t is a triangular wave function. This f of t is a triangular wave function. I hope you had understood the problem, and the problem is very important problem. So this problem gives you the idea about the difference between rectangular wave as well as triangular wave. Okay, you have to know the difference and you have to work out this problem. Okay, the problem here has a simple idea, but you have to do very carefully. So thank you all for watching this video. Thank you all once again.